Okay, so let's start this very simple introduction to digital electronics. So in this video, what I'm going to share with you is the difference between an OR gate and an AND gate, which are the most basic components of any digital circuit. So what is an AND gate? Let's try to explain it with a picture. So we will draw an AND gate as this, and basically it contains two inputs and one output. You see, it's like a half moon, whereas the OR gate is a very slightly different shape. So we have here a straight line and here a curved line. And it has also two inputs. We illustrate them as if there were two wires, and one output wire. So as we are talking about digital electronics, what we care here in these wirings is not about the voltages or currents, but only on the logic levels. So we call a logic level high a 1 and a logic level low a 0. So basically we have two different logic levels, 1 or 0. Depending on the combination of ones and zeros at the inputs of these AND or OR gates, we will have different logic outputs, and that's what makes the definition of a combinational logic gate, such as the AND gate and the OR gate. In the case of the AND gate, for instance, if we have two zeros at the inputs, we will have a 0 at the output. The same for the OR logic. If we have two zeros at the inputs, we will have a 0 at the output. Okay, so what else? Exactly the same if we have a high level at the inputs. In both cases, we will have a high level at the output. So here we have all the combinations: 0, 0, 0, 1, 1, 0, and 1, 1. In the case of the OR gate, as we said, if we have two low values, we will have a 0 result. And if we have two high values, we have a 1 result. The same for the AND gate. Basically, the difference are between all of the two combinations. In the case of the OR, it's a sum of both terms. So if you have any of the inputs as 1, the output will be a 1. On the contrary, for the AND gate, it's like a multiplication of both the inputs. 1 per 0 is always 0. And 1 per 0 is always 0. So that's it's wrong. So why is the name that receives each of them? In the case of the OR, it's clear. If one or the other are 1, we have R1 at the output. And in the case of the AND, both inputs needs to be 1 so that the output is 1. So we have just described the two main components, the two main basic elements of any digital circuit. We will have some other combinational gates, such as the OR NOT gate, which basically inverts the input to the output. And then we have some other more complex gates that we will explain later. The XOR, the XNOR, the NAND, and the NOR. But for this first video, I think that we have covered the most basic elements.